Hi all, hopefully you have enjoyed revising on this week. We have done this as an assessment week to leave you to your own devices a little bit more. There's been lots of things set on Hegarty Maths which should give you a flavour of the kind of things that might be in this assessment, but obviously there will be blank spots. If as we're going through this you're a bit stuck with something, listen to the topic heading and use that Hegarty search bar to find it and help you to revise a little bit more. This was a 45-minute paper. That's because there's 40 marks available. It's basically half of a GCSE paper, and then you are given essentially half of the time. That's 1 mark per minute, and then a little bit of checking time as well. It might be that you go faster than that, which is absolutely fine, but you should be aiming to use that full 45 minutes to make the most of every minute of that time that you've been given. There is a reason there are 45 minutes. So we're going to start looking at question number 1. This is an indices question. This is definitely something you were asked to revise, and so it should have been something that was quite straightforward if you have. What I'm going to do is evaluate each one of these things, bearing in mind that it is not a calculator paper. So 2 to the power of 5 is 2 multiplied by itself 5 times in total. So I've got 4, 8, 16 and then 32 for this 2 to the power of 5. 64 to the power of 1/2 means the square root of 64, which is 8. 4 to the power of 3 means 4 multiplied by 4 multiplied by 4, which is not the easiest one to do, but is 64. 16 is just 16. Oh, I've missed 8 to the power of 1/3. This is the cube root of 8, which is 2. We've then got just 16. And then 64 to the power of 0, well, anything to the power of 0 is 1. We need to start with the smallest number when we're doing this, but we can't just start with the small numbers here. We have to remember to use the ones that were in the original question. So when we're putting these in order, we should get 64 to the power of 0. I'm just going to cross that one off to remind myself I've used it. My next one is then going to be 8 to the power of 1/3. We then get 64 to the power of 1/2. We then just get 16, 2 to the power of 5, and then that leaves us with 4 to the power of 3. Our next question is about some buses leaving stations. We've got 2 different buses that leave for Acton and for Barton. They leave every 24 and 20 minutes. They both leave the bus station at 9 o'clock, and I want to know the next time they leave the bus station at the same time. There's lots of different ways to do this. You could start listing the times and see when they're the same as each other. Or we could work through and find a lowest common multiple of 24 and 20. Again, lots of different ways to do this. We could do that using a Venn diagram and prime factors, or we could do it by listing. I'm going to go for listing this time because it isn't that big of a number. I'm going to end up with 20, 40, 60, 80, 100, 120, 140, 160, and I'm going to leave it there for now. And then my multiples of 24 are 24, 48, 72, 96 and 120. I'm now going to stop because I can see that I've got 120 here. Now these are 120 minutes, which is 2 hours, and so if we started at 9 AM and we add 2 hours, that's going to get us to 11 AM is the next time that they leave at the same time. We've then got a lovely reverse percentages question. So the normal price of a TV is reduced by 30% in a sale. So I'm going to start with my normal price and my sale price, and I'm going to reduce it by 30%. The sale price is £350. and I want to work out the normal price. You're probably likely to have wanted to use some decimals here, but I don't want us to do that because this is a non-calculator paper. So I'm going to start thinking in the same way, that this is 100% and this therefore would be 70% with 30 taken off. That means that 70% of this thing I don't know, the normal price, is going to be £350. I can divide both sides there by 7 to get me 10% of this thing I don't know, which is going to be £50. And then multiplying by 10 would get me to 100% of that thing I don't know, which is going to be £500. And that gives us our final answer. It is really tempting to use those decimals, but in a non-calculator paper it is way more complicated. This next question was a volume and density question. Reading through, the clues should have been like this. We've got a cross section of a prism, so this is just one flat side, and then we're given the length of that prism as 2 meters. So what I'm going to do is just extend this picture out a little bit to imagine what this would look like as a full prism, knowing that this section here is 2 meters or 200 centimeters in depth. The prism is made from metal, and the density of that metal is 8 grams per centimetre cubed. Lots of you will use the formula triangle for this, which is absolutely fine, but just in case you can't remember that triangle, I'm going to show you a way around it now. So your density here is grams divided by centimetres cubed. Grams per centimetre cubed, grams per centimetre cubed. Grams is a mass, and it's been divided by a volume. I want to find the mass, so what I'm going to do is I'm going to rearrange this formula by multiplying up by volume. So I get that mass is the density multiplied by the volume. We know the density already. We don't know the volume, but we can work it out from all of this information. To find the volume of that prism, I need to do the area of the cross section times by the depth, or the length in this case as they're calling it. Well, I know that the area of my cross section is slightly more complicated, so what I'm going to do is I'm going to cut this shape up into 2 parts. I'm going to cut it down here and give myself parts A and B. Part A is a rectangle that is 7 by 2, so we've got 14 centimetres squared there. Our next one is a little bit different because I've not got the full 7 anymore, but I still have this 2. This 7 was made up of a 2 and this part here, which is a 5 centimetre. So we've got 2 by 5, which is going to get me 10 centimetres squared. So in total, I've got 24 centimetres squared for my cross section. Then all I've got to do is to decide which of these 2 measures for length to use. Well, these were in centimetres squared, so I'm going to go for centimetres here for 200 centimetres, which is going to get me 4,800 centimetres cubed. We aren't done though, because we did need the mass, not just the volume. But to get there, what we need to do to find the mass is my 8 multiplied by 4,800. There are lots of different ways to do this, but whatever you do, we should have ended up with 38,400 grams. You needed to use your units here. That will have given you a mark because there is none on this answer line. That also does mean if you wanted to, you could have written this as 38.4 kilograms. Our next question is a Venn diagrams question. It is a set notation and probability question, so we need to remember what that set notation means. We've got a Venn diagram with the numbers from 1 to 11, so that should tell us that everything is always going to be out of 11 in these questions. Working out the probability of A and its union with B. So this is A union B, which again is still quite hard to understand. The union is what I'm looking at if I'm looking at A or B, if we were to use kind of normal everyday speak. So to be an A or B or both. The things that are in A or B or both are this one, this section, and this section. It's just not these things on the outside. So we should get 8 out of 11 for this one. We also are then asked to have a look at the probability of the complement of B. Again, sounding quite complicated, that just means in normal everyday speak, not B. So anything that isn't in B. That's these things here. These are in B, but they're also in A, but I can't include them. And then these things aren't in B either. And so we've got 7 out of 11 things that are not in B. Our next question is a speed, distance, time question. What I'm going to do is draw myself a diagram using each piece of information. Harry travels from Appleton to Brockley at an average speed of 50 miles per hour. He then travels from Brockley to Cantham at an average speed of 70 miles per hour. So far I've used these two pieces of information. Harry takes a total time of 5 hours, so this whole time is 5 hours from Appleton to Cantham, and the distance from Brockley to Cantham is going to be 210 miles. I'm then asked to calculate the average speed for the total distance travelled. It's important to remember that if I'm asked to do an average speed, that's the average distance. Sorry, that's the total distance over the total time. We know the total time here is the 5 hours we've got here. We just need to find the total distance. What I'm going to do is actually look for a speed, a distance and a time in every single little section here. And then that should help me to figure out what's going on across the whole picture, because I can add those things together. We know from the question that this distance was 210 miles. So the time is going to be given by distance divided by time. So I'm going to do 210 divided by 70 to get us 3 hours. If this section was 3 hours, that must mean that this section is 2 hours to make up the 5 in total. And to figure out the distance, I then need to do the time times by the speed, 2 times by 50 to get 100 miles in that first section. This means that my total distance is going to be 310 miles. That's 310 miles in 5 hours, which gives us 62 miles per hour in total. Our next question is a quadratic sequences question. The first thing we need to do is to use an nth term rule to find the 4th term. So this is going to be 4 squared plus 3 times 4 and take 2. 4 squared is 16 plus 12 and then take 2 is going to get us 26. I'm going to show you an alternative method to what's on the sheet, because I know a lot of my students and others in Manacroft have definitely learned it. It might not be what you've learned, but it might be something you prefer to what's on the Hegarty clip or the word solutions. I know it's definitely something I do. But whatever the method, we should get the same answer. It's just our way of getting there that's slightly different. So, to start off with, I'm going to rewrite my sequence so that I can use it. When I look at this, I can see that I'm going plus 6, plus 10, plus 14, and plus 18. This isn't very much use to us because it's not a linear sequence, it's a quadratic. So what we need to do is look at our second differences, so the difference between the differences, which is 4 each time. This second difference of 4 means that this is like the 2n squared sequence. We need to half this second difference and stick it in front of the n squared. I'm almost going to create as a table here, so I've got tn or our nth term, and I'm going to write in my 2n squared sequence. Well, my n squared sequence starts at 1, so doubling that gets me 2. We then get 3 doubled, which is 6, 9 doubled, which is 18, 16 doubled, which is 32, and then 25 doubled, which is 50. We're then looking at the difference between these. So 1 take 2 gives me negative 1. 7 take 6. It's not quite right, is it? It should be 8 because I've got 4 times by 2, not 3. Gives me 8. So I'm going to take negative 1 here and negative 1 again and again and again. This means that I have got a constant difference of minus 1 from the 2n squared sequence, which gives me 2n squared minus 1 as its nth term. Question number 8 was about Pfizer, and it was a probability question. So Pfizer has got 10 coins in a bag. There are 3 £1 coins and 7 50p coins. She's going to take 3 coins at random from the bag, and we want the probability she gets exactly £2.50. I'm going to draw a probability tree for this. So she could either take £1 or 50p each time, and that doesn't change the whole way along. This is quite a big probability tree because we've got a lot of factors to consider. If she's got 10 coins, she's going to start with 3 of them being £1, so get 3/10, which leaves us with 7/10 here. This is where we've got to start being more careful. And you'll actually notice in the word solutions that we weren't that careful the first time we looked at this question. We crossed out 2/10 and wrote 2/9 instead. That is because we've taken 1 coin away, leaving us with 9, and that 1 coin we took was also a £1, leaving us with 2 of them. We've then still got 7 of these because we've not picked one, and then we've got to think really carefully about what happens in the next few. These should be out of 8 because there's now only 8 coins left. If we've picked £1 twice, there's only 1 left there. However, if we've picked a 50p, there's still 2 of these and 6 here. We can then fill in the rest in the same kind of way. These are out of 9 and these are out of 8 because they are the second and third picks. If I've picked a 50p, there's only 6 left, but there'll still be £3. If I have picked £1 and a 50p, this will be 2 8s and this will be 6 8s because there's still 6 left. If I've picked 2 50p's, there's going to be 5 left and there will still be £3. The thing I've got to decide now is getting exactly £2.50 and which pathways give me that. So a pound plus a pound plus a pound is going to get me £3, so I don't want this one. £1 plus £1 plus 50p gives me £2.50, so I am bothered about this one. A pound plus 50p plus a pound, what's the same, just in a different order, so £2.50 for this one too. A pound plus 50p plus 50p is only going to get me £2. The next one, 50 plus a pound gets me £2.50, which is exactly what I was after. 50 plus a pound plus 50 is going to get me £2, which is not what I want. 50 plus 50 plus a pound is going to get me £2 again, which I'm not bothered about. 50, 50 and 50 gets me £1.50, which I'm not bothered about. So the pathways I want to take look like this. Or I could take this one. Or last but not least, I could take this one. So my calculations I need to do are the calculations for these pathways. So I do 3/10 multiplied by 2/9 multiplied by 7/8 for that first one. For the second one, 3/10 multiplied by 7/9 multiplied by 2/8. And the last one, 7/10 multiplied by 3/9 multiplied by 2/8. If I multiply those and then add them together, I'm going to end up with 126 over 720. This one was 42 over 720, again 42 over 720, and again 42 over 720. This is because all of my fractions have got a 3 somewhere on the numerators, a 7 and a 2 as well, and then the same denominators, 10, 9 and 8. So they're the same fraction, they're just in a different order. Our next question was a lovely algebra question. There is a lot of manipulation that needs to go on here. What I'm going to do is deal with each part separately for now, and then put them all together. So if we start with this section, x minus 1 all squared means x minus 1 multiplied by x minus 1. If you didn't remember that, that is going to cause you an awful lot of stress. And so what we need to do is use our grid method or something like that. Maybe that's using arrows over our brackets to remember how to do this. So I've got x minus 1 multiplied by x minus 1. That's going to give me x squared minus x and plus 1, or x squared minus 2x plus 1 altogether. And then I'm going to look at this next section, which is negative 2 multiplied by x minus 1. This is going to give me negative 2x plus 2. So now I'm going to take negative 2x and add 2. And then I've got take 3. To tidy all of this up, all I'm going to do is look at my numbers. So this is 3, take 3. Well, that means that they disappear. And that's going to leave us with x squared minus 4x, which is equal to 0. To solve this, what we need to do is then factorise. Factorising gives us an x on the outside and then x minus 4 in a bracket. That means that either x is 0 for this section here, or x is 4 to make that bracket 0. And then we're solved. Our last question is a vectors question. Lots of us find these very, very hard, so I'm going to try and colour code as much of this as I possibly can. So we've got some equilateral triangles. Because these are equilateral, that leaves us with lots and lots of pathways that are very similar to each other because they go in the same direction. So anything that slants in this direction is an A. So that means that this is also an A. Because we can't write in bold, what I'm going to do is underline my vectors to show that I know that they are a vector. And then we've got this B, which is our horizontal line here. That means that this one here is also a B. And so is this one up here. The direction is very important here, so I'm also drawing on my arrows to show the directions I can see. It also tells me that M is the midpoint of CD, which is not particularly useful at the moment, but it's nice to know that this is halfway. So what I'm going to do is I'm just going to write half and half here to remind me of that later on. I need to write A to B in terms of A and B. So all I'm doing here is following some pathways. I want to get from big A to big B. So to get from A to B, there's two ways I can do it. I can go straight down there, but we don't know what it looks like. Or I can follow my pathways. I need to go down A, which gives me negative A, and then across B, so plus B. This is a perfectly acceptable answer, or you could write it as B take A, so that you've got the positive first. We then need to show that OC is parallel to MB. O to C is a slightly more difficult pathway again, but we've already allowed for the fact that we know what this bit is. So I can go from O to B and B to C. So OC is where I'm going to start. I'm going to go O to B, and then I'm going to go from B to C. So I've described my pathway as this first step. So across here and then up here. O to B and B to C is A plus B, or B plus A, depending on which way you want to write it. To show that something is parallel means that you need to show that one is a multiple of the other. So they go in the same direction, but they may be different lengths. So what we're looking for is something that's got an A and a B, and we can factorise something else out. So now I need to find B to M. Thinking about the pathways that I can see, there's a few different ways I can do this. I'm going to follow B to C and then C to M personally. So B to C plus C to M. Though you could do it as B to D plus D to M. The reason I've decided to go the way that I have is because A to B is parallel to C to D, or C to M, and that means that they are the same vector. And we actually found A to B earlier on as A minus B. Sorry, B minus A. And because I want to go in that direction, C to M made way more sense. So B to C we know straight away is A because we had it before, and then C to M is 1/2 of our answer for A, B minus A. This is A plus 1/2 of B minus 1/2 of A, and then simplifying that down, that's 1/2 A plus 1/2 B. This is so similar to what we had before, but these have got halves in front of them, so I'm now going to do that factorise step. That's 1/2 of A plus B. So OC and BM are parallel as one is a multiple of another. And if you want to, you could write that even further by saying that B to M is 1/2 of O to C. But you don't necessarily need that for the marks. There was a huge amount of work that went into this. This last question is very, very difficult. So if you got some of it, you will have got some of the marks. And I'm not at this stage expecting us to be able to get this perfectly. But if you did, that's absolutely brilliant. There is going to be another set of these that come out in the next couple of days. And there will be walkthrough videos for those as well. So make sure that you're looking up anything that you need to revise that hasn't already come up, anything that you might want to go over again now you've seen these solutions. Otherwise, stay safe and we'll see you next time.